Okay, get this. We're diving into some real-life Armageddon stuff today, but hopefully with a less dramatic ending.
Hopefully.
Our source material is a recent CBS News article about Asteroid 2024 YR4.
Yeah.
It's being called a city-killer asteroid hurtling towards Earth.
Right.
But before anyone starts building an underground bunker,
Yeah.
let's break down the facts and separate the sci-fi from the reality.
Absolutely.
So what is the deal with this 2024 YR4?
Well, it's a real chance it could hit Earth.
Oh, okay.
But thankfully a small one.
Okay, good.
The article mentions it's about the size of a football field and was just discovered last December.
Oh, wow. Last December. That's pretty recent.
Yeah, it is. And that late discovery is actually pretty typical for asteroids, especially those relatively small.
Yeah, I guess it makes sense they'd be hard to spot.
It is. They're essentially hurtling through space, often in unpredictable patterns.
Wow, so they're like cosmic ninjas sneaking up on us.
Sort of, but don't worry too much.
Okay, so seriously though, what are the chances of 2024 YR4 actually hitting Earth?
Right now, scientists estimate the odds at 1.6%.
1.6%. So not huge, but still.
Yeah, it's small, but considering the potential consequences,
Yeah.
it's enough to put it on the radar of folks like NASA's Center for Near-Earth Object Studies, or CNEOs.
CMEOs?
They're the ones responsible for monitoring these space rocks, asteroids, meteors, the whole lot, and calculating those impact probabilities.
So they're like the cosmic traffic cops?
Yeah, you could say that.
Okay, 1.6%. Not exactly comforting, but hopefully those odds will go down as they gather more data, right?
That's what we're hoping. Further observation allows us to refine the trajectory and get a clearer picture of the risk.
Okay.
But let's say the worst-case scenario happens, and 2024 YR4 stays on a collision course.
Oh, boy.
Where are we talking about impact?
Right.
What kind of damage are we looking at?
Yeah, the article mentions some pretty wide-ranging impact zones.
It does.
The Eastern Pacific Ocean, South America, the Atlantic, even parts of Africa and Asia.
Yeah.
It's almost like playing a terrifying game of cosmic darts.
It is a bit like that.
But what does that actually mean in terms of impact on the ground?
Well, the CBS article draws a comparison to the Tunguska Event in 1908.
Oh, yeah, I remember reading about that.
So that's when a smaller asteroid, maybe the size of a house, exploded over Siberia,
Oh,
flattening millions of trees over 800 square miles.
800 square miles. That's huge.
It is. That's twice the size of Rhode Island.
So even without directly hitting the ground, that asteroid packed a serious punch.
It did. And it's incredible to think that much energy was released from something relatively small.
Yeah, so if a house-sized asteroid could do that much damage, imagine something the size of a football field.
Right. It's no wonder they're calling this one a city killer.
Definitely not a situation to take lightly.
No, it's not.
But we're not just sitting here waiting for the sky to fall, are we? What are we actively doing to prevent an impact like this?
Well, that's where things get really exciting, at least for someone like me,
Okay.
who spends all day thinking about this stuff.
I can imagine.
Remember that seemingly impossible mission?
Dart?
That spacecraft successfully nudged an asteroid off course in 2022, proving we can actually deflect these things.
Oh, yeah, I remember that. It felt like we were living in a sci-fi movie.
It did a bit.
But if it worked on one asteroid, couldn't we do the same thing with 2024 YR4 if it becomes necessary?
In theory, yes, DART was a game changer, demonstrating the potential of kinetic impactors for planetary defense.
It's like a giant cosmic billiard ball.
Pretty much. But scaling up to a larger asteroid like this one presents a new set of challenges.
Ah, I see.
We may need different, more powerful deflection methods.
So what are the other options? The article mentioned things like lasers and gravity tractors.
Those are definitely ideas being explored, though they're still in the early stages of development.
Okay, lasers and gravity tractors. Are we headed into like Star Wars territory?
Kind of lasers, for instance, could vaporize a small portion of the asteroid, creating a jet of vapor that would act like a thruster, nudging it off course.
Okay, so like a tiny rocket engine on the asteroid.
Yeah, you could think of it that way.
I can wrap my head around that one, but how does the gravity tractor concept work? I'm having trouble picturing how gravity could move something as massive as an asteroid.
Think of it this way. Imagine a large spacecraft positioned near the asteroid.
Okay.
The spacecraft's own gravity, though weak,
Yeah.
would exert a tiny pull on the asteroid over time, like a cosmic tugboat, slowly but surely changing the asteroid's course.
Wow, it's amazing to think we could manipulate gravity to our advantage like that.
Yeah, it's pretty incredible.
But something tells me these high-tech solutions aren't exactly cheap.
No, they're not.
Or easy to implement.
They're not easy either.
What if we can't deflect 2024 YR4 in time?
That's where evacuation plans come in.
Evacuation plans.
We have a potential impact date, December 22, 2032.
2032, that's not that far away.
No, it's not. But it does give us a decent window to prepare if deflection efforts fail.
So we basically need to evacuate everyone in those potential impact zones.
Pretty much.
That seems logistically impossible.
It would be an incredibly complex undertaking for sure. And it raises a whole host of ethical and political questions about who gets to decide, who gets prioritized, and how we manage resources in a global crisis.
Yeah, that's a whole other conversation we should probably have.
Definitely.
So we've established that this 2024 YR4 is not a situation to take lightly.
Absolutely not.
But we're not just sitting ducks. We've got some options on the table.
We do, and we're constantly working on new ones.
Okay, so we've covered what this asteroid is.
Right.
The risk it poses.
Yeah.
And what steps we might take to address it.
Exactly.
So now let's delve into some of those fascinating what-ifs.
Yes, let's. The ethical implications of planetary defense are complex.
Yeah.
And often overlooked.
Yeah, we've talked about what we can do, but what should we do?
Right.
That's a conversation we need to be having now, not when an asteroid is hurtling towards us.
Exactly. We need to be proactive, not reactive.
Evacuation plans, that's pretty intense.
Yeah.
I mean, can you even imagine the logistics of moving potentially millions of people out of harm's way?
It'd be crazy, right?
And even if we could pull something like that off, would every nation really be willing to cooperate?
It's a good question. And it's one of the thorniest issues when it comes to planetary defense. Would a nation be willing to put up billions of dollars, maybe even trillions, to deflect an asteroid that might not even hit them?
That's a tough one. It's like this isn't just a science problem, it's also a human problem.
Absolutely. We're talking about global responsibility, resource allocation. Yeah. Who gets to make the final call in a planetary crisis?
And all the political maneuvering that goes along with it.
Oh, yeah, for sure. Imagine a scenario where the only way to deflect an asteroid is to push it slightly so it hits a different country.
Oh, wow.
Suddenly the stakes become even higher.
Yeah, that's a whole new level of international tension.
It'd be like a cosmic game of hot potato.
No one wants to be left holding the asteroid when the music stops.
Exactly. And that's why we need clear international protocols and agreements long before we face a real threat.
So we need to be having these conversations now.
Absolutely. We need to establish a framework for decision-making, resource sharing, coordinated action. Because when you're dealing with a global threat like this, going it alone simply isn't an option.
So we've talked about the challenges of international cooperation, but let's zoom out a bit. What does all this mean for the average person? Should we be living in a constant state of fear about a potential asteroid hitting Earth?
That's a good question, and it's important to find that balance between awareness and anxiety. It's good to be informed about the risks, but we can't let them control our lives. Asteroid impacts are extremely rare events.
Okay, that's good to hear. But I have to admit, whenever I hear about a city-killer asteroid like this one, I can't help but think of those Hollywood disaster movies.
I get it. Those movies are designed to entertain, not necessarily educate. They often exaggerate the risks and downplay the science.
So how do we avoid falling into that trap of sensationalism? How do we stay informed about freaking out?
I think it comes down to finding credible sources of information. Organizations like NASA, the European Space Agency, the Planetary Society, they're doing great work tracking asteroids, developing deflection technologies, and educating the public.
And that's one of the things we're trying to do with this podcast, right?
Exactly, breaking down these complex topics and making them more understandable.
But even with all the information out there, there's still a lot of uncertainty, right? We can't predict the future with 100% accuracy.
That's true. There will always be an element of the unknown when it comes to space. But the more we learn, the better prepared we'll be to respond to whatever comes our way.
Speaking of learning, I'm curious about the historical aspect of all this. We've been talking about asteroids from a very scientific perspective, but how did people in the past view these celestial events?
That's a great question. For much of human history, these objects were seen through the lens of mythology and superstition. Comets in particular were often viewed as omens of bad luck or divine messengers.
Right, like Halley's Comet in 1066, it was seen as a bad omen for the English before the Battle of Hastings.
Exactly. Without a scientific understanding of what they were seeing, people naturally turned to stories and beliefs that made sense to them at the time.
So when did that shift from superstition to science start to happen?
The invention of the telescope in the 17th century was a major turning point. Suddenly we could see these celestial objects in greater detail, observe their movement, their composition, and begin to unravel the mysteries that had surrounded them for centuries.
So instead of seeing them as supernatural phenomena, we started to see them as physical objects governed by natural laws.
Precisely. And that marked a huge shift in our understanding of the universe and our place within it. It was a transition from feeling like subjects of the cosmos to seeing ourselves as explorers and investigators.
I love that. It reminds me of that Carl Sagan quote, "We are a way for the cosmos to know itself."
Absolutely. And that spirit of curiosity and exploration is really at the heart of everything we're talking about today. It drives us to learn more about asteroids, to develop ways to protect ourselves, and to ultimately ensure the survival of our species.
It's amazing to think we've gone from fearing these objects to studying them, and now potentially even using them to our advantage.
It is pretty remarkable.
But even with all our scientific advancements, there's still a sense of awe and wonder when we look up at the night sky.
Definitely. There's something humbling about realizing how small we are in the grand scheme of things. But it's also incredibly inspiring to think about all that we've learned and all that we have yet to discover.
So we've talked a lot about the potential threats from space. But what about the opportunities? Asteroids aren't just things to be afraid of, are they?
Not at all. They're also a source of incredible scientific value. By studying asteroids, we can learn more about the formation of our solar system, the origins of life on Earth, and even the potential for future resource extraction.
Resource extraction? You mean like mining asteroids?
Exactly. Asteroids are rich in valuable minerals and resources that could potentially be used for everything from building space infrastructure to powering spacecraft. It sounds like science fiction, but it's a field that's gaining serious momentum.
Wow, it seems like we're entering a whole new era of space exploration and utilization. But before we get too carried away with visions of asteroid mining, let's bring it back to Earth and our main topic, planetary defense. We've covered a lot of ground today, but what's the key takeaway for our listeners?
I think the most important message is this. While the threat from asteroids is real, it's not something to obsess over or lose sleep about. We have the scientific knowledge, the technological tools, and increasingly the global awareness to meet this challenge.
It sounds like we're finally starting to take our cosmic neighborhood seriously.
We are, and that's a good thing. It's about time we recognize that we're not just inhabitants of Earth, but citizens of the solar system. And with that citizenship comes a responsibility to understand and protect our planetary home.
Well said. Well, I think it's time to wrap up this part of our deep dive.
This is good.
But before we go, is there anything else about asteroids that you find particularly fascinating or mind-boggling? Something that keeps you up at night, but in a good way?
Let me think. One thing that always gets me is the sheer variety of asteroids out there. They come in all shapes and sizes, from tiny pebbles to objects hundreds of miles across.
Wow.
And their compositions are just as diverse, ranging from rocky and metallic to icy and even organic.
It's like they're a miniature representation of the vastness and complexity of the universe itself.
Exactly. And that's what makes studying them so captivating. They're like cosmic time capsules, holding clues to the history of our solar system and the processes that led to the formation of planets like Earth.
And who knows what other secrets they might hold.
Exactly. That's the beauty of science. There's always something more to learn, something new to discover.
So many secrets in those asteroids, tiny cosmic treasure chests just waiting to be opened.
Yeah.
But for now, let's bring it back down to Earth and what we're doing to protect ourselves from these potentially hazardous objects. We've talked about deflection strategies, evacuation plans, the ethical considerations of planetary defense. Where do we go from here? What are the next steps in ensuring our planet's safety from these cosmic threats?
Well, it's a multifaceted approach.
Okay.
First and foremost, we need to continue investing in early detection.
Early detection.
The sooner we can identify a potential threat, the more options we have for dealing with it.
Makes sense.
So that means building more advanced telescopes and developing better tracking systems.
So it's like building a better radar system, but on a cosmic scale.
Exactly. We need to see these asteroids coming from as far away as possible.
And are we getting better at that?
We are. Telescopes like the Vera Rubin Observatory in Chile are specifically designed to scan the skies for these faint, fast-moving objects.
Wow.
And new algorithms are being developed to analyze the data more efficiently to help us identify potential threats even faster.
So we're on it.
We're getting there.
That's good to hear. But detecting an asteroid is only half the battle, right? We also need to be able to do something about it if it's headed our way.
Of course, deflection technology is crucial. The DART mission was a huge proof of concept, showing that kinetic impactors can work. But we need to keep pushing the boundaries of what's possible. We're talking about lasers, gravity tractors, even nuclear options.
Nuclear options. That seems a little extreme.
It does, but it might be necessary in certain situations.
I guess it's kind of ironic we spend so much time trying to prevent nuclear war on Earth.
Right.
And now we might need to use nukes to protect ourselves from threats from space.
It's a strange world we live in, and it just goes to show that planetary defense isn't just a scientific or technical problem. It's also a social, apolitical, even a philosophical one.
It really makes you think about our place in the universe.
It does.
Yeah.
And our responsibility to safeguard our planet. Not just for ourselves, but for all the other species that call Earth home.
Yeah, it's not just about saving humanity, it's about saving the whole biosphere.
Exactly. A large asteroid impact could wipe out life as we know it.
So we've talked about detection deflection. What about the human element of all this? How do we prepare people for something like this, especially when there's so much potential for panic and misinformation?
Communication is key. We need to move beyond the sensationalized headlines and focus on providing accurate evidence-based information to the public.
So less chicken, little more calm and collected science.
Exactly. We need to empower people with knowledge so they can make informed decisions and support the efforts to protect our planet.
It's like we need a global shift in mindset, from seeing ourselves as helpless victims to active participants in planetary defense.
I think you're right.
Yeah.
It's about recognizing that we have a stake in this responsibility to future generations.
Well said. Well, I think that brings us back to the central theme of our deep dive today.
And what's that?
Knowledge is power.
Absolutely.
The more we understand about asteroids, the risks they pose, and how to deal with them, the better off we'll be.
I completely agree.
So to all our listeners out there, I encourage you to stay curious, stay informed, stay engaged.
Yes.
This is an important conversation, and we need everyone at the table.
We do.
And with that, I think it's time to wrap up this deep dive into the world of asteroids and planetary defense.
Sounds good.
Thanks for joining us. And until next time, keep looking up and remember the future of our planet is in our hands.
Well said.